Alright, let's begin. Start off, we were optimizing color selected 3D and shader color class. To optimize the shader file, we're pre-computing the matrices, so with the buffer, we only need the worldview projection as the variable instead of splitting them up, and that means the other buffer only has the color in it. This allows us in the vertex shader to do one multiplication instead of three multiplications we were doing before. Changes I made to the shader color class include converting the camera data structure into a single variable because we're always multiplying these three matrices together. I kept the object data as a structure because I felt in the future we'd be more likely to add things to this structure as opposed to the three matrices that are being multiplied. In the CPP file, because we made the matrix data into a variable rather than the struct, it's now a size of matrix. And when we send everything over, we send the matrices, we do world view and projection, multiply it together, update the sub-resource, set the color, update the sub-resource. Over here, we are creating it as we did with the shaded color. And when we draw the scene, we send the matrices, send the color. Got our box out of that. And then when we close, we delete the shader class, which will release the buffers. Next up was to do that but better. So to do that but better, I added a new variable called camera matrix, and the camera matrix will multiply the view and projection together anytime the camera gets updated. This means that when we are rendering multiple objects, instead of multiplying view and projection every time we send the matrices over, we can pre-compute this number once, or this matrix once, and use that pre-computed answer 5 different times, which will make it more efficient. So over here, we only multiply the camera instead of multiplying the view and projection. Color remained unchanged. Next up was talking about the repeated pyramid, which wasn't too complicated. We got all of this lined up. I probably should have showed the bottom first, but it is lined up. And this was the code for it. I followed your Vin-Tind idea because I thought that made sense to try and make things more convenient instead of trying to keep track of all the different numbers. And then next up was the six-sided texture, where each side had a different texture on it from the same image. So we have the top lined up with the back, tell by the T, where the top of the T is facing, and then the under part of bottom is lined up with the back. And all the other letters are lined up properly. So here's the code for that. And the final thing, while I'm showing this, final thing to discuss was the shader texture class assignment. So that one, the way I tackled that was I followed what we did for the shader color. Main changes was adding the texture coords. We have a camera data buffer and instance data buffer for the texture shader class, or the texture shader file, I should say, the HLSL. The main difference is set texture and resource and sampler. The way we do this is we take the texture, set that to context with whatever we set our current context to be. This is because in the texture file, when we set to context, or the texture CPP, I should say, when we set to context, it sets the shader resource and the sampler automatically, so we don't have to do it inside the class. And then finally, we send camera and send world. Over here, we end up creating the shader texture class, and then we create the textures here, so that when we draw the scene, well, first we send the camera matrix once, like we learned. We don't need to do that multiple times. And after that, we send the world, set the texture, resource, and sampler, send to context, and render. We do that for each object. And then once we're done, we delete the textures and delete the shader class and delete the models so that everything's deleted and released. Finally, we were talking about further work. There wasn't too much of a change for the crate. Some things looked clearer, but overall it looked relatively the same. 512, I didn't notice any difference for. However, because of the magnification for test 2, the linearization had some weird effects based off of the different addresses and filters you could do. So for the wrap setting, the texture was tiled beyond 0 and 1. So that meant there was a red pixel beyond the white pixel and vice versa, which led to white blending to red and red blending to white. Mirror didn't really have this problem because the textures were flipped, so that means white moved the texture next to white was another white, and red was also another red. So the only difference was towards the middle of the texture from 0 to 1. That had the blending effect, but beyond that, there was no blending. Border was a weird one because there was only blackness beyond the 0 and 1, so that it tried to blend with that blackness. And finally, we had clamps, which looked almost identical to mirror because any value beyond 0 and 1 just clamped to 0 and 1, so it didn't look beyond for the linearization. And finally, to talk about performance, I used what you did in class with the 15 by 15 by 15 cube of objects. I tried using each of these objects to see if I got different results, but they were all relatively the same. Most notably, the best option was to send the camera matrices to the shader once, but to not pre-compute them on the CPU. That was slower. That's it.